Welcome back. So we are going to continue working on our 2D platformer. It's going to allow us to talk about a couple of new things. So we're going to implement jumping logic, which is going to involve a concept called casting. We are going to create animation. So when the player moves around, we'll be able to change the animation so that there's a run animation, an idle animation, a jump animation. And then we will wrap up with talking about how to separate our code between update and fixed update, which was one of the things we hinted at, that we shouldn't be putting all of our code here that manipulates the physics into update. We should really be doing physics code in fixed update, and we'll get to why and what that looks like towards the end of the video. So real quick review, we learned about tile maps. Tile maps allow you to paint individual tiles using the tile palette into a layer. You can create multiple layers, so we have a ground and a background tile map, and we can sort them using the sorting layer. We can sort our player, which is a 2D sprite, using the sorting layers as well. We were able to create these. These are custom. We, in our script, learned how to use, instead of doing transform.translate, we learned how to manipulate the velocity of a rigid body to create kind of a horizontal movement for our player controller. So I actually want to pull up the documentation here to highlight something. So when we started working in Unity, we were initially starting with transform, and transform has a rotate method and a translate method. And these are great for getting simple movement. Like we can just move an object 1 meter forward, or we can rotate it around the x-axis. And if we do that inside of update, we can create the appearance of movement by having it rotate multiple times a second. And those are great if you have really arcade style games that don't really need physics. But as soon as you need physics, you kind of have to leave transform.translate behind and transform.rotate behind and move on to a new way of manipulating your objects in the world. And I'll mention, for 3D games, there is a character controller component, which is an option for you if you don't need all of the physics that comes with rigid bodies. I'm not going to really talk about them in this video. We're going to use rigid bodies to move around. So once we have committed to using rigid bodies, we know we need physics in our game. That means that we want to only use the rigid body methods to actually move things around in our world, or specifically to move things that have physics associated with them around in the world. And so there are a couple methods that I will highlight, methods and properties. So we have position and rotation from the rigid body. So if we're talking the rigid body component, we can say the position is something, we can say the rotation is something, and that will teleport the object into that new state. So this isn't actually trying to move the object according to the physics simulation. It is as if the object has been teleported somewhere. So those are options if you do need to teleport your object somewhere. There are also corresponding methods, move position and move rotation, which do try to respect the physics engine's interpolation settings, which means that when you move to a new position, it treats the object as if it has moved from its past position to its new position, or its past rotation to its new rotation. So these will give you smooth movement as opposed to sort of teleportation. We've used add force before, and there's add explosive force and add torque. So these are allowing you to push an object, apply a force either linearly, like moving it in space X, Y, and Z, or a rotational force where we are actually pushing it around an axis so that it rotates. And then there's also velocity and angular velocity. And so we used velocity last time, and these allow us to reach into the simulation and specifically override the velocity or angular velocity. And if we look at the documentation, it's like in most cases, you probably don't want to do this. It's unrealistic. You probably want to add force. But in our case, we're creating a platformer where the player controller doesn't necessarily need to move realistically. In fact, sometimes unrealistic behavior, like being able to stop on a dime and move immediately from the right to the left when you press the left key, that's actually what you want in a platformer. So we actually reached in and used the velocity here to create our horizontal movement so that we could have that really tight control for a player controller. So let's flip back to Unity. We've finished reviewing, and we can start talking about jumping. So before we actually implement jump, what we need to do is talk about what we want to happen when we jump. So if we have our player, that they've like spawned in the world. We're dropping them in from here. We don't want them to jump immediately. We only want them to be able to jump when they touch the ground. So we need to figure out some way to check, is the player on the ground and they've pressed the jump key, then they're going to be allowed to jump. And as soon as they're in the air, we want to disable the ability to jump, because in this game, we don't want to do double jumping or triple jumping. So we will need to constantly be detecting whether the player is over ground or not. That's going to involve a concept called casting, and there are a couple of ways to do it. Let's pull up the documentation to talk about it. So the physics class in Unity, this has a couple of cast methods. We have box cast, line cast, Raycast, sphere cast, and let's look at Raycast. So it says that it casts a ray from some point in some direction for some distance against all the colliders in the scene. So if we look at the documentation, that's giving us back a Boolean when we pass in those things, and is letting us know, did we hit any other colliders in the world, according to the physics engine, which is really useful. So if you have some laser in your world and you need to know whether that laser is hitting anything in the world, you could do a raycast to check. You can also, there are methods for like raycast all, which will give you back all of the things that you hit, and sphere cast all, and box cast all. So those are useful in the physics class. And then there is also if we look at the collider 2D, there is a cast method. So not only can you ask the physics engine to do a cast, you can also ask a collider to go ahead and do a cast, which we're going to specify a direction. We are going to get some result of things that we hit. We'll say how far, and then there's some other parameters that we're not going to need, but it takes the collider and casts the collider itself some distance, and then returns what you've hit. So that would mean in our scene, it's essentially like we're going to be able to take our whole collider here, shift it down slightly, and say, you know, did you hit anything? And it will tell us whether or not we hit a tile that has a collider. And since all these ground tiles in our world have a collider, this would tell us currently, yes, you have hit something. And as soon as we move up, when we do that like shift down and check, there's nothing underneath the player. So it's going to tell us that we're not colliding with anything. So you can use any of the ray casting methods that we talked about, or the casting methods. I'm going to use the collider because it's useful since it matches the same size as the player. We can kind of tell whether or not, like here in this situation, the player is over the ground or not, as opposed to if you did a ray cast where you're just passing a single line down from the player, you wouldn't catch that the player was currently over the ground when they're standing here, because maybe we're casting the ray from the center of the player down. So we are going to use the collider cast method to be able to check whether something is below the player. And then when we get to the point that we actually want to jump, we have a couple of options. We could reach in and manipulate the velocity temporarily to say that the player's velocity should be some positive number so that the player goes up. We could move position, pick some like distance above the player and move the player there. But I think the easiest thing for us to do is to just add a force. So when the spacebar is pressed, the jump key is pressed, and we're over the ground, we will go ahead and add a vertical force. We will make it an immediate force so that the player goes flying up, and then gravity pulls the player back down. So let's start doing that. We are going to need our documentation handy. So we've got this cast method. We pass in, once we have the collider 2D, we can call this cast method. We pass in a direction. It's going to give us back an array of these structs, Raycast Hit 2D. It is going to allow us to configure how far we want to cast. So we don't want to cast infinitely, because then, you know, we could be like 5 meters above the ground and we'll still be considered on the ground. So what we want to do is point downwards and specify some small distance to say, like, just check like a 1/10 of a meter below the player to see whether if they're over the ground. And let's take a quick look at the results. So don't have a link here, so let's just Google, we'll search for the documentation for Raycast Hit 2D to just take a look. So Raycast Hit 2D, this is a struct. It gives us some information. So it tells us the point where the ray hit something in the world. It tells us the normal direction for that point of impact. It tells us the collider. It tells us a few things that will be useful for us later on to use. So what we're going to need to do here, if we look at what it returns, it's going to tell us the number of things that have been hit. So this is kind of a performance thing. We are actually going to be passing in an array that we have filled with blank structs for Raycast Hit 2D. It's going to return back to us the number of things that it hit. So it's basically going to say how many things did it just put in the array and fill in with values. And so some of this is like a memory optimization thing that we will allocate the memory for these structs up front. We will never have to reallocate them during the middle of this cast. So it's just a performance thing to keep in mind as we're heading into our code. And it tells us that that array is not resized. So if there isn't enough room in the array for the number of things that were hit, those are going to be discarded. The other thing to point out is we're not going to use it in this one, but there is a way to filter the things that you hit. So you can create a filter that allows you to say like, oh, I only care whether I hit the ground, or I only care whether I hit items. If you're curious to implement that in your own game, check out the Context Filter 2D. But let's jump into the code with this knowledge in mind. So what we're going to need to do is get the collider. So we want a collider 2D collider, and we want also to create that array of the Raycast Hit 2D structs. So private Raycast Hit 2D, I'm going to call it hits. It's going to be a new array of Raycast Hit 2D, and let's say we're going to pick 16 is how many spots in memory we want to reserve. So we can detect up to 16 things being hit in one cast, which is honestly plenty for what we're doing. We may not even need 16. One thing here is that it's complaining to us that this field hides something that comes from something that comes from higher up in the inheritance tree for this mono behavior inheritance tree. And it's a deprecated thing, so you really shouldn't be using that inherited member. So what I'm just going to do here is use the new keyword to let the compiler know, like, oh, I'm fine with hiding that deprecated collider variable so that we can use the collider variable here. So let's grab our component, get component, collider 2D. And then what we can do down here is let's create a section where let's check for landing on the ground, and this will be our jump only if on the ground. So now we could do our cast. So it's going to tell us back how many things were hit, and we can talk to our collider and we can cast. We can specify that we want to cast in the downward direction, vector 2.down, and we will pass in that array that we created. We'll call it hits, and we then can specify the distance that we care about. Let's just take a wild guess, and we'll use a big number. Let's say it's a full meter that we care about. So we can then use num hits to determine whether or not we are currently on the ground. So if we are on the ground, that means that there's more than one thing, that there's one or more thing that we've hit. So we can express that with just saying num hits greater than 0. So this will make it true if we hit anything, false if we didn't hit anything, and we can actually flip back to Unity and check this out. So to debug this, let's flip our inspector into debug mode, which means that we can see our private fields. So we can watch is on ground down here. Right now it's true, and as I grab the player and drag him up, is on ground flips to false. And if I drag the player back down, is on ground flips to true. So there's this invisible area below the player where we are checking for a whole meter whether the player intersects with anything on the ground. Instead of just using is on ground here to check that, we can, I'm going to flip this back to normal, we can do this from inside of our script. So there is, let's say, debugging, a method called Debug Ray, and this will allow us to specify a point, a direction, a color, and a duration, and it will draw a line in our scene that matches that and it will exist for whatever duration we specify. So we can kind of just draw a line pointing down from the bottom of the player, and we will then be able to see how big that distance is. So we need a starting point. Let's say Ray start, and this is going to be, we kind of want to grab the bottom of the player collider, the bottom center. So let's create a new vector 2, and we are going to use the collider's bounds. So collider.bounds gives us access to the center, the minimum, the maximum. And so for the x, we want the center x, so that gives us horizontally centered. And then when we want the bottom of the collider, we'll just say collider.bounds.min for the y. So we've now got a point that starts at the bottom middle, and for direction, let's specify the vector 2.down to point the ray downward, and we will scale this by however big our distance for checking is. And actually, let's make this a field. So private float, let's call it ground distance check 1f. Use that here, use that here for our ray. Then we can draw the ray, so ray start, ray direction, color.red, and let's have it hang around for 1 second. And whoops, this is lowercase r. So we can comment this out later when we're done debugging, but this will draw a ray that matches what we are actually casting downward. So we can kind of see this. It will show up by default in your scene if you have gizmos selected, so you can see the red ray here. And if you have gizmos selected in your game view, you'll be able to see gizmos when you're debugging inside of Unity. These won't show up in your build, so when you build it for a player, don't ever rely on these gizmos for anything. But now we can see, as I move the player around, where that ground detection is, which this is an incredibly huge ground detection, which means that I can kind of, I could jump from distances that wouldn't really make sense given the graphics. So let's see, let's change something in our script. Previously we were using this is jumping Boolean. You know what? We're going to simplify our code. If we did the more complex version, we would include this Boolean. Let's get rid of this Boolean here and from up here. So we're just going to ditch is on ground check to speed things up, or ditch the is jumping check. So if jump is pressed and we are on the ground, then we're allowed to jump. And if we run it, when we have that meter long ground detection, that means that we can kind of jump from, whoops, make sure we save, come back. That means that we can jump from like midair. So as I'm hitting the space key multiple times here, I'm able to jump a bunch of times. So really what we want to do is shrink that ray to be as small as we can kind of get away with. So if we come back here, instead of doing a full meter, maybe we'll do like 0.05 meters for our ground check. And if we run it, you can see now we're only able to, even though I'm pressing space a bunch of times, only able to jump when we're on the ground. And so if we wanted to take this a little bit further, there's probably technically a situation where we could get like a small double jump happening if you press spacebar fast enough. when you're initially on the ground, and that's where we would use the kind of is jumping Boolean. But I think for the sake of brevity, this is good enough for us right now. And as we're moving around, ooh, look, there's one bug that I want to fix while we're at it. You can see that if you are pressed up against a wall and you keep moving to the left or keep moving to if you're pressed up against a right wall and keep moving to the right, you kind of stick to the wall. That's actually from friction. We are constantly pushing the player into the wall, and the friction is keeping the player basically stationary and suspended. So usually when we're making a platformer, we want to take control of the physics using physics materials. So we've seen that before in 3D, and now we can do it in 2D. So physics material, we will create a physics material 2D. We will call this the player, and we want to make sure that the friction is set to 0 and bounciness is set to 0. And then what we're going to do is apply it to the rigid body here. So now if we run this, we get the player moving around still, but if we press up against the wall, since there's no friction, we're just going to slide down the wall. So we've got basically all we need for our player to move around, and now we want to start talking about visual feedback for these movements, because right now our player just kind of moonwalks around, which doesn't look great. So what we want to do is hook this player up to some animations that we control via a script. So when we're jumping, we'll have a jump animation. When we're running, we'll have a running animation. We'll have an idle animation. So all of this means we need to take a brief detour into talking about how the animation system works inside of Unity before we can get to the point of actually getting our player animating. So we're going to look at animating a few objects in our world before we take it to the complex level of making our player animatable. So what we want to do is add a folder for animations, and I'm going into Pixel Adventure 1. I'm going to grab this box, bring it into my scene, sort it to the foreground, rename it to be box, place it above this platform, and let's pretend that this is a box that has an item in it or some collectible, and we kind of want it to do a little dance in the air to attract the player to it so that the player knows that they can kind of run up and smash it and grab whatever's in it. So inside of Unity, the animation window, just window, animation, bring it over to this monitor. When we create a clip, this basically gives us the ability to animate almost any property inside of Unity. So we can animate the position, rotation, scale, we can animate the color, we could change which sprite is being used, which is if you do frame animation, that's how you would create animations that go through all the frames. We can actually animate properties of our own scripts if there were some reason that we wanted to do that. So the animation window is actually really, really powerful. So don't follow along with what I'm about to do. I'm going to actually show you the wrong way to animate this box, but it'll allow us to talk about a few important concepts before we actually animate the box hovering and dancing around. So I'm going to click on the box. I'm going to have my animation window open, hit create, and I'm going to put this into my animation folder. I'm going to call this the box hover animation. And that creates over here a box animator controller and a box hover animation clip. We'll talk about the animator in a little bit, which will allow us to orchestrate multiple clips together. But for our purposes, all we need to know is that this clip is the thing that the box is hooked up to play from this animator here. So it will run that box hover animation by default, which means that if we record some things in here, that will allow us to actually play that animation when the scene loads. So the way that animation works, if you haven't done animation before, is by inserting keyframes into a timeline. So what we can do here is scrub around in this time. So this is 0, this is 1 second in. So maybe at 0, what we'll do is add a keyframe by right-clicking on position. And as soon as we do that, we get this keyframe at 0. It's showing us what the values are. If I inspect this here, it's telling me the X, Y, and Z have all been inserted as a keyframe. If I move over to 1 second in, and then maybe I move the box over here and I add a keyframe, that has just set things up so that at 0, it should be at 0.45, 3.20, and then it should be at this new value over here when we reach 1 second. And the animation engine handles all the values in between. So we set up keyframes, and then we let the animation engine handle moving the object so that we hit those keyframes. And if I hit play, we can actually see the object moving around, previewing the animation. And if we hit play on our scene, we'll see that that actually runs as soon as our game loads. So some other things with this animation window, the record button allows us to actually insert keyframes by just changing things. So for instance, if I'm going to insert a keyframe for rotation 0 here. I'm going to go to 30 seconds, and then I'm just going to change this. Let's change it to be 180 and hit play. You can see that it recorded that rotation, that Y rotation, as a keyframe just because I had this record and I changed a property. So this is really useful if you're changing a bunch of things. You don't have to right click and add key every time. So now let's talk about why this is not the way that you should animate your box, aside from the goofy animation that I created. Part of the problem is that if we animate the box's position directly, and let's say I want to put the box over here, I want to create a prefab where I can put it in multiple places. If I go ahead and hit play, as soon as the animation starts, it takes over and it puts the box at those coordinates. So those global coordinates. So it's impossible for us to reposition the box. So what we want to do, instead of animating the actual coordinates of the box, these would be global coordinates up here. We want to get rid of this animation. And I'm going to get rid of the animator on the box. We want not to animate the box's global coordinates, but to animate its local coordinates. So if we wrap it in an empty game object that we can call our hovering box, put the box in here, and then what I'm going to do is let's zero out this. So it's at 0, 0, 0, and let's put the box at 0, 0, 0 within the empty game object and grab the parent and put it into position. What I can do is apply an animation to our hovering box, so create a clip for hovering box, and then animate the child moving, which means that I can move this up and down, and the parent can still be repositioned in the world. So let's see what that looks like in action. I am going to open up my animation window again. I am going to make sure I have hovering box selected. I'm going to create an animation. I will call this hovering box, save it into my animations folder. And now what I want to do is, instead of animating the hovering box position, animate the child element. So I am going to hit record. I am going to drop in a keyframe for 0, 0, 0. I'm going to hop to 30 seconds or half a second in, and maybe I'll shift this up. What looks good? Maybe about 0.5, so 0.5 here in the Y. And then when we hit 1 second, we will bring it back down to 0. So if we play this, our box hovers up and down. So the nice thing about this, let's stop this playing, stop recording, is that if I run my scene and I grab the parent object, I can move it around. And that's because our box, its local position, is being animated because it's a child of the hovering box empty game object. So we could also add a little bit more here, like maybe we want this thing to flip around. So I'm going to add a keyframe for rotation here at 0, and then maybe halfway through the animation, I'll make it go to 360. So it'll do a little quick flip as it's animating. If we wanted, we could add all sorts of things. So maybe we add a keyframe here for color, and somewhere right before it finishes its flip, we could change it to be like an orange color with the tint, and then I can copy this keyframe by Control-C and then paste it in here. So now we're basically going to turn orange and then turn back to white right after the flip is finished. This whole thing will loop. So you can kind of animate whatever you want. Most of the properties inside of Unity are animatable by just playing with them in the inspector, or you can hit this add property to sort of explore the components that you have and see what properties are animatable. I will post the Unity manual, which goes into a lot more depth for how this tool works. I will just briefly mention that there's a curves window. So the dope sheet allows you to see your keyframes and where they are. The curves allows you to see how the values change over time. So if I click on one of these and then hit F to focus on it, we can see here is our Y value, or our Z rotation over time. This is the curve that it's following. And you can edit the curve and change how the value goes from one value to the next, which can have drastically different effects on the feel of the animation. It's a little bit beyond the scope of what we have time to do today, so check out the manual. There's a whole lot you can do to breathe new life into your animations. So I'm going to stop this, I'm going to undo that, and what we could do now is actually turn this box into a prefab. So if I go to my assets, create a new folder, prefab, drag my hovering box in here, I can now drop multiple in the world, and they each have that animation attached to it. So if I run the scene, they'll all do their thing as soon as the scene starts. So this is really useful for animating properties of objects in your world. You can animate like targets that the player is trying to hit or land on using the animation system, using the animation window to keyframe those properties. The other thing that's common is, and especially in this pack, to have animations that aren't meant to like be where we move the X and Y position, but we actually change the frame that's being rendered. So if we look at the apple here, this is something that has a bunch of frames that have been generated by Pixel Frog ahead of time and rendered out in a sprite sheet. And so we can actually slice this up and then run this animation, which will allow us to place something with a whole bunch of frames that it runs through, which we need to do because that is how our virtual guy is set up. So here's the double jump, here's the hit, here's the idle, here's the run. So I'm showing you both ways to do animation. There's the frame-based, which is what we're doing now, and then there's the non-frame-based where we just animated properties ourselves. So let's grab the apple, and I didn't slice this ahead of time, so I'm gonna get a quick review. I'm gonna change this to multiple. Open up the sprite editor, slice by cell size, go by 32, 32, slice it, apply, and when that's done, we should be able to pop this down and see all of the different frames separated out as individual assets. I'm going to bring one of these into the scene. I'm going to rename this to be Apple. I'm going to sort it to the foreground. And let's bring it up and put it over this other platform here. We're going to need our animation window again. And in this animation window, we will create a new animation, making sure that we have Apple selected. Put this in here. I'm going to call this the Apple animation. And instead of manipulating the properties and hitting record, what we want to do is just grab all of these, drag them in here, and hit play. And we can see it's playing through that animation. It's playing through it super fast. And that's because we have set it up so that each tick over here, it's changing frames, which is way too fast. This is set up to sample at 60 frames a second, but our animation is actually 20 frames a second. So that's on the itch page. The artist has listed what the animation rate is. So what we can do is just change the samples down to 20. And now we've got the animation playing at, whoops, let's change the samples down to 20. There we go. Now we've got the animation playing at the speed that the artist designed it at. And if you don't have the samples pulled up, you might have to go down here and click Show Sample Rate, which will allow you to change this. So maybe you want to speed this up or slow it down. You could do like 40. Whoops, gotta hit Enter after typing the number in, and you got a slightly faster animation. So let's put that back to 20. We can close this. I can now turn my apple into a prefab. Let's grab it, drag it into prefabs. Now we could drop multiple apples in the world and each of them will play that animation by default. So at this point, we've learned enough about the animation system to be able to actually use that same knowledge to hook up animations for our player. So what we're going to want to do for our player, which is distinct from what we did for the apple and this box, is that we're going to have multiple clips. Here, each of these, we created one clip that played through the animation. Here we're going to have multiple clips. We're going to have run, idle, jumping, falling, and we're going to have to orchestrate the logic to switch between those things. So we're going to have to dig into the animator, which allows us to implement that logic. But before we do that, let's create all of the clips that we're going to need. So inside of your Pixel Adventure 1 folder, whichever character you're using, you need to make sure that the idle, the run, jump, and fall are all set up properly, so they have the right pixels per unit. For fall and jump, it's just going to be a single frame, and then for run and idle, you're going to have to slice up those. I've done that ahead of time. I did that in the last video, so I'm going to run with these. And what we're going to do is open up our animation window to hook these clips up. So I'm going to do that really quickly. I'm going to select my player, create an animation clip. I'm going to actually create a folder in here for my player animations. And this will be, let's do the idle. Drag all of the idle sprites in here. Change the samples to be 20. You can test it to make sure it works. Good, we got our idle. I'm going to hit this drop down, create a new clip. Let's do run. Oops, sample should be 20. Make sure this works. Cool, we got our run. And we're going to make animations for fall and jump, even though they're single frames. It'll just make our logic easier to implement since we can then use the animator to orchestrate them. So here's our falling and jump. Cool, so we got all these set up. We can close the animation window, and now we want to use the animator window. So the animator window is different than the animation window. The animator window, if you click on your player, will have a bunch of nodes in it, one for each of those clips that we just created. So we've got idle, we've got run, we've got fall, we've got jump. So the animator window here, if I click on the player, we can see that we have this animator component, and then there's a controller that's hooked up. And that's actually what we have open here. So we have the animator controller called player, which has each of these clips loaded into it. And the animator system in Unity is what's called a state machine. If you haven't heard of those before, it's essentially a system that allows you to have an object, an entity that is in one of multiple states. So here, our player could either be an idle, run, fall, or jump as the states, and then we're able to create these lines between the states to transition. The animator component is a little bit more complicated than that. There's a lot of powerful things that you can do with the animator component that we're not going to touch on. Like you can have multiple layers of animations playing simultaneously. You can have subsystems, but for our purposes, you can think of it as a way to manage which animation we're currently in, which state we're currently in. And if we run our game with the animator window open and our player selected, we can actually see it running live. So we can see that by default, it went into its idle state, and here we can see the idle animation playing through. We can see its progress in blue. So we're going to use this as we're hooking it up to kind of debug where we're at with our animation. A couple of overview things. We've got entry, any state, and exit. And these are special nodes in our animator system, in our state machine. Entry, if we hook something up to entry, that means that when the animation system starts running, this will be the state that we end up in. So we have idle set, and if we right click on any of the others, we can set it as the layer default, which means that now if we play it, instead of going to idle, we go to run. Any state is useful, and we're going to use it later for making transitions from any state to another state. So if we set up a transition from any state to jump or any state to fall, that means regardless of how many things we have in our system, we can create a transition that goes from any of the states into fall or jump. And exit is useful for saying that you've passed through all of the animations in the system, it's done, and it'll restart back at the entry. So that'll become a little bit more clear when we actually play with them. But what we should do now is make sure idle is set as our default. And let's explore creating our first transition. Let's go from idle to run. So for idle to run, we kind of want to create a transition that's based on the player's speed, but let's see what Unity gives us by default. If I right click on idle, make transition, choose run, and then if I click on this, I can see the parameters for that animation. So we can see that it goes from idle to run. I could preview this transition by clicking play. And what it's doing is, with the settings that we have configured here, it's waiting a certain amount of time through the idle animation and then kicking into the run animation. If we run our scene, we should see that. We got a blue bar, and then run kicks off, and we're in the run state. This isn't what we want. So we actually want to get rid of some of these settings so that we can actually take control of when this transition happens. So we're going to turn off exit time, which means that it's a constant time. So when idle reaches a certain amount of playtime, then you switch to the next state. We're turning that off, and we're going to use conditions, which will allow us to implement some logic and say, instead of some fixed amount of time from idle starting to go into run, we should only go into run when the player is moving a certain speed. The other thing that we're going to turn off is this transition duration. And so some of these settings are really nice for non-frame based animations. So in 2D world, if you're doing spine animations, these can be useful. And in the 3D world, when you're actually modeling and animating 3D models, these can be really helpful because they allow you to blend between two different states. But in the case of frame-based animation, there isn't really a good way for automated blending to happen. So we're just going to turn off these. So no duration, no exit time, and then we can come down here and start implementing conditions. And we're seeing a warning here that a transition either has to have a condition or an exit time to be valid, otherwise it's going to be ignored. So we definitely have to add some conditions here for our animation system to work. And conditions they run based off of parameters. So over in the Animator tab, we can flip between layers and parameters you can think of as variables that we can store inside of our Animator controller that we can manipulate via scripts and read via scripts, and we can use them to control movement from one state to another. So we can click the plus arrow. We have an option for a float, an int, a bool, or a trigger parameter. We're going to be using float and bool today, but you could easily use int, and trigger is something that it's like a bool except you flip it on momentarily. So let's add a float, and we will call this our x speed. So we're going to want to set this from our script, but we'll be able to play with this in the animator and see that it's working. We want to set this to be some value that's based on how fast the player is moving horizontally. And we don't care, we're using the word speed here because we don't care if it's positive or negative. If they're running to the right or running to the left, we just want to know how fast they're running, not which direction. As soon as we add that over here, we can click on our transition. We can set up a transition and use the drop down to select any parameters that we have for this animator controller. And we can say if the x speed is greater than, let's say, 0.1 meters per second, we will then go from idle to run. So I'm going to move these out of the way. And what we can do is play with this value live in the inspector while we are running. So I can change this to be 0.2 and we switch to running. And then if we were to say stop and go to 0, we hopefully would get back to idle, but we haven't made that transition yet. So let's go ahead and do that. Make a transition from run to idle. We're going to do a similar thing. We're just going to say instead of greater than, less than 0.1. We can run it. Now we can modify our speed. Let's go up to 1. We're running. Go back to 0. We stopped. So I forgot to take off the exit time here and turn this down to 0. So let's run that again. 1 to 0. We're stopped, and we stopped on a dime. So looks like that's hooked up properly. We've got something that can go from idle to run, and now we want to start looking at fall and jump. So let's move this over here. Now at this point, since you've seen how to make transitions, you could conceivably think about how you might do idle to jump and fall. So maybe it's possible to get to jump from idling. Like if we're standing still, we can definitely jump. And if we're running, we can definitely jump. So we could start by like making a transition here, and making a transition here. And then you'd have to think, well, when we leave jumping, maybe it's possible to go from jumping to idle. So we're going to have to create a transition here, and maybe we'll have to create a transition here. And then when fall comes in, it's like, well, they could walk off a ledge without jumping. So we're going to need a transition here. And fall could go to idle. Maybe fall can go to running, and running can go to fall. So already we've got a lot of transitions, and this would be a lot of conditions to go ahead and configure over here. So what we're going to do instead, I'm going to Control Z a bunch of times. Since we have a situation where we can really, from any state in our system, end up jumping or falling, we're going to use the any state. So if we create a transition from any state to jump or any state to fall, we'll be able to move into those states regardless of how many we have over here. So maybe we extend the game and we have idle and run and crouch and slide, and we want to be able to jump from any of those. By setting up our structure this way, we'll have a more flexible animation system, and it'll be less work to maintain. So when should we transition to jump, and when should we transition to fall? We know that in our script we will be able to check whether the player is on the ground, and since the player has a rigid body, we can ask for its velocity. So jumping would mean that we are not on the ground and we're going up. And falling would mean we're not on the ground and we're going down. So we can create a transition from any state to either of these, and then we're going to need to create a float, which will be our y velocity. And here we're using velocity because we want to know whether the player is going up or down. And then we can use a Boolean is on ground. And this will be able to set from our script to indicate whether the player is on the ground. And with both of those, we can set up our transitions. So any state here, turn off the duration. So we want to go from any state into jumping if we're not on the ground. So is on ground is false. And so we can add multiple conditions joined together here, and the y velocity is greater than 0. And we want to go from any state into falling. Let's turn off the duration again. If we are not on the ground and our y velocity is less than 0. So let's test this out. With any of the things that we've configured, we don't even have to go to scripting. We can just like manipulate these in the inspector. So let's say the player, they have a positive y velocity and we're not on the ground. Actually, let's start this. So I'm going to start this checked to say that we're on the ground, since that matches our current state here. Okay, so we're on the ground. Y velocity goes up to 1. Uncheck this. We end up in the jump state, which looks right. And then we go -1. We end up in the fall state. And then we land on the ground again. So we're not quite in the right situation yet. We've got the entering jump and fall from any state. But what we need to do is leave jump and fall when we land on the ground again. So this is where our exit is going to come in. So I'm going to drop this in here. I'm going to make a transition from jump, and fall to exit, and no exit time, duration 0, no exit time, duration 0. And both of these, we are going to create a condition. If we're on the ground, we can leave this animation system. And same here, on the ground, leave the animation system. And the way that this works is that as soon as we hit exit, the player's still around, this animator is still running. That just means that we end up back at the entry and fall into whatever our default state is. So let's give this a shot. We're on the ground, our velocity is 0. We go up and we leave the ground. Then we start going down. And then we hit the ground and we're back in idle. And since we have transitions here to go to run, that means that we can easily go directly from idle to run if the player was jumping and moving horizontally. We can also check and see, so if the player were to just like walk off the ledge without jumping, that would mean that we would have a negative y velocity. We're heading down and we're not on the ground, and we instantly go into fall. And then when we land, we end up back in our idle. So we've actually got everything we need set up here in our brain for our animator, so this animator controller. And what we want to do is go to our script, and now we need to hook these things up that we've been testing to our script. And actually, that is probably the easiest part of what we're going to do. So what we need to do is, inside of our script, get access to this animator, and then from the animator, we can set floats and bools from the parameters ourselves. So we can just calculate the speed, the velocity, and this Boolean and pass them to the animator. So let's do that. We need to create a private animator. We need to get the component. And this works because this script is attached to the player right next to the animator, so we can use getComponent to get access to that. Then inside of our update, at the end, after we've done all of our calculations, we should go ahead and if we look through here, we can, if we start saying set, there is a set bool, there is a set float, there's a set trigger, and a set int method or set integer. So each of these, let's look at the float. We pass in the name that we configured. Here we go, this overload. We pass in the name that we configured and then the value. So that means that we would pass in x speed as the name, and then we would pass in whatever value we want. So let's do x speed, and you might be tempted to do player.rigidbody .velocity.x, but remember velocity has the sign component, so it will tell you positive or negative depending on which direction you're heading, and we just want the speed here. We don't care about this transition, idle to run, about which direction you're heading. We just need to know how fast you're heading. And so to get the speed from the velocity, it's just a matter of taking the absolute value. So we can take the absolute value of x, and so if it's negative, it'll give us a positive value. If it's positive, it'll give us a positive value still. So now we have the speed. We can do the same thing, animator.set float and our y velocity. Velocity with an O. There we go. Player rigid body dot velocity dot y, and then animator dot set bool is on ground. And actually that one's easy because we already have that Boolean from calculating it with our collider and casting our collider. So is on ground. I'm going to add a comment here, update our animator system after updating the player's movement. So fingers crossed, make sure I saved it, give it a play. Okay, so we end up in our idle state, which is cool to see. Already our game is feeling better. We're able to run, and we can see that as soon as our speed reaches a certain point, we start running. And as I jump and fall, we end up in the jump and fall animations. So we were able to set up our animation system, and then really easily, it was just a matter of tweaking a few things inside of our script, hook up our script to the animation system. And this, even though I'm showing you it for a player, this is also something you can easily use in your game to do all sorts of things. Like if you had a door that you wanted to be able to open and close when the player pressed a key, then what you might do is have a Boolean that you set up that is door open, or maybe you use a trigger for this, and you just flip between an animation that opens the door and closes the door. And all of that you could potentially create inside of Unity if you're working in a 3D you're working with 3D models, where you can use the animation system to just like create those open and close animations. So you have a lot of possibilities that open up by being able to use the animation system. All right, the last thing that I want to do in this video is talk about how we can separate out our logic so that the physics updates can happen inside of FixedUpdate instead of update. And I have a demo project here to show you some of what can happen if you don't do this. So I have a scene where I have this platform. It is going to be moving up. It is a rigid body that's kinematic, which means that I'm controlling its position. It's not participating in the normal physics simulation where it's getting pulled by gravity and forces are being applied to it. So it's just like an elevator platform. And I have a bunch of objects that are rigid bodies that I'm going to move. I'm dropping them onto the platform, and then they're going to move up with the platform. So if we just run it by normally, where we're doing our updates inside of update instead of FixedUpdate, and we kind of crank up the speed. It looks okay right now. Cranking up the speed a little bit. 3, 10. Now everything's starting to jitter as I'm doing this. So I'm moving up the platform right now using update instead of FixedUpdate. And then as soon as I switch to using FixedUpdate, now things are done in sync and we get a lot of smooth movement, and the physics system can help interpolate the position of objects. So let me show you the script, and then I'll run that one more time so that you can parse it out. So the script is really simple. It has a Boolean that controls whether or not we call this move function from update or FixedUpdate. And this move function, all it does is use the rigid body move position method to take the current position and bump it up slightly based on whatever speed we've passed in. So that Boolean that I was clicking, that is just controlling whether we're doing this in update or FixedUpdate. So if we run it again with that context, I'm going to start it in, it's now using update. We'll start at a slow speed. So it's moving up by 1. Now if we do it by 3, by 10, by 30, and things get crazy because we're making these updates out of sync with the physics system. And as soon as we change to using FixedUpdate, the physics system knows what to do. So takeaway from this is just make sure that when you are making your physics updates, you're doing them inside of FixedUpdate instead of update. And if you see symptoms like what we were seeing here, where things were just kind of clanking around, that can be an indication that you're maybe doing your logic in the wrong place. So let's shut this down and head back to our platformer. So the difference between update and FixedUpdate is that update runs as fast as Unity can have it run, trying to hit like 60 frames a second or maybe 120 frames a second depending on the display. And FixedUpdate is called a fixed number of times per second that you can actually configure. By default it's 50, but you can change that, you can increase that, you can decrease that. And by having that fixed time step, it can help make your physics code more deterministic. And as we're seeing here, it also means that if you manipulate physics objects, you're doing them in sync with the engine, and it knows how to handle those changes that you're making. So what I would normally do is maybe split this out into 2 scripts, an input handler and our player controller. But for the sake of time in this video, let's do it in here. And what we need to do is, inside of update, we are reading the horizontal axis and we are reading the jump button. And we kind of want to move those so that they stay inside of update, and move the rest of the logic so that it happens inside of FixedUpdate. So I kind of want to take this, put it in here, and then figure out some way that we can get input get axis and our jump button back into update. Because update is going to run faster than FixedUpdate generally, and that means that we'll be more responsive to key inputs if they happen inside of update. If we do them inside of fixed update, because this is generally running slower, you may end up with a little bit more sluggish controls. You may miss some of the key presses. So really you want to do this kind of logic inside of update and then pass the information some way into fixed update. So if we did pull this out and pull this out, the problem would be that at any moment in time, if we read the horizontal input from fixed update, we would just be getting a single frame of horizontal input. But it's possible that update could have happened multiple times since the last fixed update. And so we kind of want to hold on to and increment the horizontal input. So instead of just saying horizontal input equals input.get horizontal axis, what we can do is create a float up here, call this horizontal input, set it equal to 0. And we're going to do horizontal input plus equals whatever the horizontal axis gives us. So let's simulate that. Let's pretend that update happens 3 times before the next fixed update happens. That means that if the player were, say, holding down the right key, input.getAxis might give you 1 on the first frame, then 2, then 3. And then when fixed update happens, instead of just reading one of those key presses to get our velocity, we're actually going to accumulate them. So instead of having 1 here, we would have 3, which means that we're going to move a corresponding amount that matches our horizontal input because we're accumulating it. And we can do the same accumulation here with isJumpPressed. So let's create a Boolean isJumpPressed. And we can't, with a Boolean, do plus equals and have it run and compile, but we can do this. So we're saying isJumpPressed is equal to whatever isJumpPressed is already, or we'll read in the jump. So that means that over the 3 frames, if at any point isJumpPress flipped to true, it'll stay true when fixed update goes to read it. So then what we can do is after we have, after we have read horizontal input and isJumpPressed and use them inside a fixed update, we want to reset them so that we start accumulating horizontal input and isJumpPressed fresh now that we've already applied them to the physics system. So let's create a private void clear inputs. We can set the horizontal input to 0 and isJumpPressed to false. And at the bottom of our fixed update here, we can clear our inputs. If we save this, flip back, see if we are still with, we've still got a game working. Yeah, we can move left and right. We can jump. Things look to be working just fine. So we weren't really encountering the issue yet where we were updating the player out of sync with the physics engine, but this would be our best practice moving forward, is making sure we do our physics updates inside of fixed update instead of update. We could get more fine controlled with it and sort of separate some more aspects of this into update, but this should be good. This should have us, this should keep us responsive to inputs and then keep things in sync with the physics engine. One thing that I'll point out is that generally you can get away with momentary adding a force, like if it's when the player presses a key, jump. Like sometimes those are safe to do inside of update since it's just a single force, but anytime you're doing kind of a continual change, like if we were adding a force multiple times, as long as the space button was held down, like a thruster was moving the player, or we're kind of manipulating the velocity here over time, those are types of things that you want to do inside of fixed update in sync with the physics engine. Okay, let's take a moment to review before we wrap up. So we figured out how to implement jump using add force, and that involved figuring out how to cast the collider. We also looked at ray casting to figure out what is underneath the player. And that's something you could also do if you wanted to like do wall jumping. You could cast horizontally to say like, oh, is the player right next to a wall? Then okay, it can jump again. So that's a powerful technique that we learned. We learned how to create animations. We learned how to create non-frame based animations where we animated something moving around in Unity. We learned how to make frame-based animations where we were able to take Pixel Frog's Apple animation and implement it. We learned how to hook up multiple animation clips inside of an Animator controller to have our player have a little brain associated with it. Whoops, let's make sure we got the player here. So we've got our player's brain, and we learned that we could watch it as it's executing. And then we wrapped up with learning how to implement our logic a little bit better, where we could separate out update from fixed update. So go forth, implement this into your platformer, and I will see you next time.